Hello, today we're going to learn about slope-intercept form of a linear equation. So here I have this graph, and it is the graph of this blue line. Right here are the directions for creating this line. And I'm just going to write that down here on the bottom. Alright, so this will construct that line. It could also be written in this form, y equals. But today we're going to focus on the function notation, which is f of x equals 2x minus 1. Now, before I even get into this even more, all I want you to do is sit back, relax, and watch the whole process go down. We'll get into your notes after this. So, how do we construct this line? Well, there are two parts. We have a y-intercept, which is the -1, and we also have the slope, which is 2. That is how we're going to start. So, when you're graphing these, you want to have a start. We will always start with our y-intercept. So I'm going to label this as our start. Then, we will use the 2 to create the steepness of the line. So I'm going to switch over to the graph, and I'm just going to graph it once more. So, y-intercept, that is exactly what it sounds like. So in football, you've heard of the word interception. Now, an interception is where the ball meets a player at the opposite team. So basically when they catch it. Now, that is relatable here to the y-intercept. So the y-intercept is where the other opposing team catches a ball. And you can think about it like the guy is like standing on the y-axis, and where he catches the ball is that y-intercept. So here I have a little representation of that. So here, over here is our function or linear equation. Here we have our guy who is on the y-axis, and the ball hits that y-axis at -1 on our y-axis. So I'm going to draw in this point even more. So that is our ball, and there is no change in our x, so the x will be at 0, but our y will go down -1. So that is our y-intercept as a point. So now I'm going to switch back over here, and I'm just going to go ahead and graph that point. So it'll be at 0, -1. Position at 0, -1. We need to know how steep our line is going to be. That's where we will go to our 2, which is our slope of this linear equation. Now, slope is a rate of change. Here we will have a rate of change is change in y over change in x. Right now we have our change in y, which is our numerator. Then we just have to get our change in x, which is our denominator, but it's pretty simple. For any whole number, we can represent that whole number over 1, and it will still come out to be that whole number. Therefore, we're just going to make our change in x that 1. It's kind of imaginary, just sitting there all the time, but it's not always written. But here, we would like to represent our slope as a fraction, because we want to get that change in y over change in x. So, now we'll move back over to GeoGebra. So our change in y, we will go to our y-axis, is +2. So we will go up 2, or in the positive direction, 2. We will not make a point yet. We still have to take account of our change in x. Our change in x is a +1. Therefore, we will go in the positive direction 1, and then we'll make our point. And again, we'll start at our new point. We'll go up 2, or in the positive direction 2, and then to the right or in the positive direction 1. Create another point, and you just continue the pattern. Now we have the right side of the line, but we also want the left side of the line. So here is our slope. I'm just going to write it as m equals, or slope equals 2 over 1. Okay, 2 over 1 is the same as negative 2 over negative 1, because a negative divided by a negative is a positive, and if we have negative 2 over negative 1, we will get 2. Therefore, these are the same. I'm just going to write that in. So, therefore, we can come back here to our y-intercept, and we can go down 2, or in the negative direction 2, and in the negative direction 1, and get our other side of our line. I'm going to erase that. Now we have a greater picture of what our line is going to look like. You never just want to plot 2 points, because you're not going to get an accurate depiction of the line when you have your straight up to it. Alright, so now we're going to draw in our line. Woohoo! We have our line. Alright, so the nice thing is on GeoGebra you can check to see if your slope matches the slope of the function or the linear equation. So I'm going to use this feature here. Go to a slope. I'm just going to pick a point. Alright, so it just calculated the slope for us, and here we have m equals 2. And what don't you know? M equals 2, or 2 over 1. So great. Now we have our line graphed over here, which is what I have over here. So that was just a run through of our slope-intercept form and how to graph it. Next, I would like for you to go to your notes. So for today, we will write linear equations in slope-intercept form, and we will also graph them. So here we have the slope-intercept form of a linear equation is y equals mx plus b. Or in our previous examples, we had f of x equals mx plus b as well. And I'm just going to go ahead and write out that example that we had. And our example was f of x equals 2x minus 1. So we could have something to reference to. Alright, so now the slope-intercept form of a linear equation is y equals mx plus b. Now the m is going to be our slope, and the b is going to be our y-intercept. So we have our slope, which is just the m, and our y-intercept is our b. So in this example, here I would like to caution you, our y-intercept is not 1. Our y-intercept is negative 1. You must take the sign that is in front of the number for our y-intercept. Then, when it comes to slope, slope is not 2x. It is not 2x. Our slope is just 2, or 2 over 1. Those two ideas are very, very, very important. As you go through the examples and the rest of your problems, make sure that you write your slope as just the number, not 2x, and your y-intercept, you are taking the sign. Say, for example, we had negative 2x minus 1. Our slope would also take the sign of in front of the number. So our slope would be negative 2 or negative 2 over 1. Now I'd like to get into some definitions. We will first start out with a linear equation. So here, a linear equation is an equation between two variables that gives a straight line when plotted on a graph. So you may pause the video if you want to take time and copy that down. Next, we will go into the y-intercept and what that is. Alright, so the y-intercept is where the function hits or intercepts the y-axis. Now, thinking back to football, that interception point is right on the y-axis. So if it's on the y-axis, there is no change in x. So therefore, if we have a linear equation written in this form, the point of intersection is going to be 0, so there is no change in x, comma, b, where b is our intersection point on the y-axis. So, you might want to ask yourself this question. Will there always be a y-intercept? So that's just something to think about. And another question is, now we're talking about y-intercepts. Now, there's an x-axis, so are there going to be x-intercepts? And that's just something I also want you to think about. So you may pause this video and copy that down if you'd like, but I'm going to move on to slope and what the definition of that is. Slope is our rate of change. So how steep or not so steep our line is, which is m in our equation here. So m is the change in y over the change in x. Also, think about this little warning bubble down here. Slope does not equal mx. Slope just equals m, which is the number in front of x. Alright, so you're going to want to take a minute, pause that, and get all this down. Then, I also have this little picture representation of how you can so something that can help you remember that slope has the change of y on the numerator and the change in x on the denominator, and it involves picnic tables. So, my question to you, which table will fail or fall over? The table on the left or the table on the right? Yes, the table on the right. This table will just fall right on over because it has nothing supporting it on the right side of the table. So, this table has a y on its denominator if we make this a fraction. So see, this is just the numerator up here. And its denominator is y. It will fail, and it will fail miserably. That is this table failing. Now, if we take a look at the picnic table on the left, it has an x in its denominator. And it will not fail. It will not fall over. So I'm just going to represent this as the other fraction. So, numerator over the denominator, which is x. So, this will help you remember that when you are writing your slope, the slope is going to be the change in x will be on the denominator. Because we don't want our picnic table to be like the one on the right. That leaves the numerator our change in y. So that could help you remember which one goes on the numerator and which one goes on the denominator. Alright, so I'd like you to go through the rest of the packet, and you can use the previous video to help you fill out the rest of that. But as for today, we are done. So, that is slope-intercept form, and you have a nice day.